Okay, fine. Today's concentration is on Surds, which we call fractional indices. Fractional indices. What is the objective of this particular presentation? I would like to put it to you that I want you to understand the Surds, which are also known as irrational numbers with fractional indices. And in this particular case, this will help you, the presentation will help you understand the basic concepts relating to operations, that is addition and subtraction and multiplication, and the properties associated with the Surds. So that's what we are intend to achieve together with this particular presentation. Now, Surds are taken to be rational numbers that are expressed in the form of square roots or cube roots or other fractional indices. You should know that they cannot be expressed as exact fractions or decimals. So that's what we call Surds. Those numbers which cannot be expressed as exact fractions or decimals are what we call Surds. Let's look at some of the expression of Surds. As I've already pointed out, a Surd can be expressed in the form of roots, where you have a is a non-negative integer, and also a is not a perfect square, or not a perfect square. So when you talk about perfect square, talking about figures like 4 is a perfect square, 16 is a perfect square. So when you find the square root to give you a whole number, okay, that's a perfect square. So in this case, those which are not perfect squares can be given as a square root of 2. If you try to figure out what is the square root of 2, it will give you not a perfect square, to be a number with decimal points. Okay, equally for square root of 3 or square root of 5. But in this case, just to demonstrate, 4 is not a Surd because it's expressed as the square root of 4 is expressed as 2. Okay, so that is a perfect square. So the square root of 2, square root of 3, square root of 5, these are not perfect squares. Therefore, they are Surds. Okay. Now, we need to also learn how to simplify Surds. So how do we simplify Surds? We can factorize the number inside the root sign into its prime factors. That's one way we can easily do that. Simplify the Surd by taking out pairs of the same factors from inside the root. Let's look at these two examples. If you look at the square root of 12, it can be expressed as a square root of 2 times 2 times 3. 2 times 2 is 4, times 3 it is 12. So in this particular case, you factor out these prime factors 2 times 2. So when it comes out of this square root sign, this one will be the square root of 4, because 2 times 2 is 4. So you find the 2 comes out of the from the under the root. So then you express it this way: 2 multiplied by the square root of 3. So that's how we simplify this Surd, which is square root of 12.
So I'm not seeing the slides.
Oh, let me just okay. Are you able to see now?
Yes.
Okay, fine. So you can see that I'm trying to show you how to simplify Surds. Okay, I've already said that from the definition here, I've said a Surd can be expressed as in the form of root of a, where a is a non-negative integer and also a is not a perfect square. So 4 is a perfect square because when you find the square root of 4, it will give you 2. Okay, give you 2. That is a perfect square. Even if you had to put square root of 16, it will give you 4. That is a perfect square. Now if you want to find the square root of 2, let me see. Square root of 2. Okay, so here you are. You have 2, square root of 2. It will give you 1.41242. This is not a perfect square. But if you have a figure like, for instance, 16, find the square root, find this 4 is a perfect square. This one is a perfect square. So surds are those which give a non-perfect square, which are not perfect squares. Those are what we call surds. Are we together? Okay. So in this particular case, we are seeing 4. The square root of 4 is 2. This is a perfect square. But the square root of 2 is not a perfect square. So the square root of 3 is not a perfect square. Even the square root of 5 is not a perfect square. These are examples of surds. So that's what I was talking about. Okay. So I went on to say, let's see how we simplify surds. Let's see how we simplify the surds. To simplify a surd, I said one of the ways is to factorize the number inside the root sign into its prime factors. What are factors? Factors are numbers that are multiplied to each other or with each other so that you get what is known as a product. So those are what we call factors. So I've given you some 2 examples just to demonstrate that. Look at the first example, this one, which is showing you a square root of 12. So the square root of 12, to factorize that one or simplify this surd, you come up with the prime factors. So this will come to be the same when you look at 2 times 2 times 3. Because 2 times 2 is 4, times 3 it will be 12. So once you have this expression, 2 times 2 times 3, then you can factor out these 2. Okay, if you multiply that one, it will be 4. So 4 times 3. So you can factor out you can factorize, or you can find the square root of 4 and it will give you 2. So if you get 2, you bring it out of there, you bring it outside under the square root sign. So it comes out here, that will be 2. That will give us now 2 times the root of 3. So that is a simplification of this surd, which is the square root of 12. We also have square root of 20. Okay, again you identify prime factors. You can have 2 times 2 times 5, which will amount to the same square root of 20. Then 2 times 2 is 4. Square root of 4 is 2. So 2 is factored outside. So you have 2 multiplied by square root of 5. So that's how you simplify this surd, which is square root of 20. Are you following?
Yes.
Any questions? Okay, fine, fair enough. So that's how we simplify surds. Let's move on and see rules that need to be applied to simplify surds. Rules that need to be applied to simplify surds. So I have these before me, 3 rules. Okay, and start we look at these 3. First one, which is where you have square root of A times square root of B is the same as having square root of A times B, or finding the square root of the product of the 2 integers. The product of the 2 integers. This A is an integer, B is an integer. So when you have the product of 2 square roots of A and B, this is the same as finding the square root of the product of the 2 integers. That's what it means. So to demonstrate this, I look at this example. For instance, you have square root of 5 times square root of 2. is the same as finding the square root of 5 times 2, okay, which is going to simplify as the square root of 10. So that's what it means here. That's how you deal with surds when you are looking at the product. Then again, there is the division. When it comes to another operation, the division. So when you are dividing, you say square root of A divided by square root of B is the same as square root of the division of the two integers. So in this case, A divided by B under root, that's square root. So for instance, if you have square root of 5 divided by square root of 2, it's the same as under root division of 5 divided by 2. So that's what it is. Okay? So that's a rule you're supposed to follow to simplify the surds. At times you can also have, we have looked at the rules relating to multiplication. We have also a rule relating to division. Now what of the rule relating to addition and subtraction? That's the third one. So if you have A multiplied by square root of C plus B multiplied by square root of C is the same as having the A plus or minus B then multiplied by square root of C. Okay, so for instance, if you have here 3 multiplied by square root of 2 plus 4 multiplied by square root of 2 is the same as getting 3 plus 4, which is 7, then the common root of 2 with both factors. So you are going to have 7 times root of square root of 2. So if it means addition, what is going to differ is the sign here. Okay, what you are going to have in this particular case, you are going to have 3 minus 4, which is negative 1. So for surds, we don't put negative 1, you just put neg 1. It means there's a negative 1 here. Then the common root of 2, which is the outside here. So it is the negative 2 basically. That's what we have. Okay. So a word of caution, where you have root of A plus or negative root of B, be reminded that this is not the same as root of open brackets A plus or minus B for non-zero A and B. Let's look at this one. Root of 16 plus root of 9 is not equal to root of 25. That's what it means there. And the root of 16 minus root of square root of 9, rather square root of 16 times minus square root of 9 is not the same as the square root of 7. So that's what you are being cautioned about. So be mindful when you are dealing with surds about this particular important point. Are we together? Okay. The other one is the arithmetic operation with surds, as I've already started looking at that. Addition and subtractions. Just to emphasize, surds with the same root can be added or subtracted. Okay, surds with the same root can be added and subtracted. All you need to do is to ensure that the radicals, which is the roots, are the same. The roots are the same. For instance, root of square root of 7 plus square root of 3, these can be added and subtracted. So you can have square root of 7 plus 3, which is square root of 10. Equally, 2 multiplied by square root of 5 minus square root of 2 is the same as, when you look at that, this one here, it goes inside, back in, under the root, it will be 4. Because when it came out under the root, it became 2. So when you push it back, it will be 4 times 5. Then minus what? Root of 2. Okay? 4 times 5 minus root of 2. So what are you going to end up having? It will be, it will come back to the same. It will be 2 times root of 5 minus root of 2. So what is being demonstrated there is, where you have this type of arrangement, remember to be in a position to be creative enough to manipulate the figures under surds in this manner. That's what is trying to be demonstrated there. Let's move on to look at when it comes to multiplication. Okay. To multiply 2 surds, you need to multiply the numbers inside the root together. Okay. For instance, you have square root of 3 times square root of 5. It's the same as square root of 3 times 5, which is 15. So those particular rules are supposed to be followed when you are dealing with surds. Okay. So move on to look at the one which involves division. Division, we have said 2 surds. To divide 2 surds, divide the numbers inside the root. So what you have is square root of 8 divided by square root of 2. The same as square root of open bracket 8 divided by 2. So what do you get in this particular case? In the square root of 4, which is going to end up being is equal to 2. Find the square root of 4, it's going to be equal to 2. That's what we have. So these are some of the things that you need to be very much familiar with when dealing with surds. Okay, dealing with these surds. So let's look at the next point. Which you call rationalizing surds. Rationalizing surds. So this is another terminology that can be associated with surds. So rationalizing the surd is a process of removing radicals from the denominator. Rationalizing the process of removing surds from the denominator, or radicals from the denominator of a fraction. Okay, to rationalize the denominator, you require to multiply both numerator and denominator by a conjugate of the denominator. Okay, for instance, if you are looking at rationalizing 1 over square root of 3, to multiply, you multiply it by the conjugate, which is you multiply by the same denominator as the new numerator, and the same square root of 3 as the denominator. So this which you see here is what is known as the conjugate of the denominator. The conjugate of the denominator. That's how you rationalize. So when you work out on this one, you are going to see that you are going to have square root of 3 divided by 3. Okay, square root of 3 divided by 3. So if you cancel out those, we also look at the next one, where you have an expression of this type: 1 over b plus square root of a. So what you do again, you have to rationalize this by multiplying the conjugate of this denominator. The conjugate of this denominator. The conjugate is this here. That's the conjugate. The conjugate is this one here, of this denominator. Okay? So that's what you're going to end up having. So if you do that, what you are going to have, you are going to have this one multiplied by itself. It's going to end up being b squared minus a, this one. Okay, so how does it come about that? Let's look at that one. let me show you how that comes about. So we have this one. Okay, so it's this one. Okay, we can put it in parentheses since we are multiplying by itself. Multiplied by this one again. Okay, so it will be, how do you multiply this one? It will be B multiplied by B. Okay, B multiplied by B, it will end up being B squared. Are we together?
Yes.
It will be, D squared. Let me just try to look at this one. Set symbol. New equation. Or maybe I use this one. Just a minute. Set equation. Let me get this one. Okay. It will be B squared. Then that's B times B. Then there will be plus. Okay. You have B, this B here. I'm going to put here B. Okay. B, this B here multiplied by square root of A. So mean that you are multiplying this one okay. So that's what you have there. So once you have multiplied B times B, you get B squared. Then B times the square root of A, you get B times the square root of A. Then you have also square root of A times B. Square root of A times B, it will be the same here. Okay. Then you have A, square root of A times the square root of A. It will be this one. And this one again. Okay, so that's what you have. Okay. Are you following?
Yes, I am.
Okay, so that's what you have. When we simplify this, you are going to end up having b squared plus 2 1 dot then plus this last one here, which I put in brackets for one, simplifies to simply a. Okay, simply a. Okay, so this one can be simplified, factor out. You are going to end up the end product, which is down below here, this one. So
Okay.
that's b squared minus a. If you simplify this one, so it will be b squared minus a. Minus a. So that's how you get this one, which is applied here. So this one will cross out, this one will multiply this one with that one. It will end up giving you this one, the denominator. Then the numerator you multiply by 1. It will remain as it is, because this, when you multiply by 1, the numerator, it will still be the same expression here. But this down here, you multiply this one and that one, it will give you a negative. Okay, so that's how it is done. Okay. So we have simplified the surds in this manner. The conjugate, you have a negative here. See the conjugate, this one, the conjugate, you change the sign here, you have a negative here. So that's what happens here. So in this particular case, the conjugate has a negative here. So as a negative, when you multiply it, it will be this times that. I'm just expressing the bottom one, which has a negative here. Okay, so that's how it is done. And this one, sorry, this one is a negative here. So meaning, not this one. So this one will come out like that, and giving out a negative from the other side. Giving out a negative on the other side. So that's how this one crosses out. Okay, that one crosses out, but there is a negative here. So this one, there is a negative here. So when you multiply this one to leave you with the negative outside here, and then you multiply the 2, it will give you the square root, which is a. So it will still retain the negative here. So then you are going to have find out the expression as b squared minus a. Are we together? Have you followed?
Yes, sir.
I was just trying to explain what you end up having here, why it's coming to be b squared negative 1 here, finally. It's because when you multiply this and that, it will give you this, which I've shaded here. But this numerator times 1, it will still maintain the same expression on top because you have just multiplied b by 1. So that's how it changes to this type of expression. Okay, so that's what you should understand. Then we move on. It calculated this one, and it demonstrated how you deal with the Surds operations, which is subtraction, addition, multiplication, and division. The other thing that you need to be comfortable with is simplification. How do you simplify a Surd? So we have looked at how do we simplify a Surd and how we deal with the operations relating to a Surd. When we talk about operation, we are talking about the addition, subtraction, division, and multiplication. So that's where we end, unless there are other questions. Tomorrow I want to look at another topic. Basically, I think we can continue looking at we can continue looking at probability so that we move faster on these particular issues.
Okay.
Is that clear?
Yes, sir.
Okay, great. Have a good night.
Okay, sir. Good night.